Meet. Okay. Okay. Good evening, Mr. Agung. Now we from midterm test group 1 gonna explain what the website that we already make. So is website created by me, Ryota, me Stefan, and my friend Ryota. So for the chapter 1, I gonna explain about the functional and non-functional. So for the functional, there's four main point that I already grouped. The first one is authentication. So authentication is the foundation. So user can register and user can log in. And the second one is core learning feature, like the material, interactive quiz, and virtual lab. And the third one is progress management. So the user can save that what they already do in the quiz and in the lab. And the last one is user profile. So the user profile is authenticated user can view their learning history on their profile page and also can edit their data. So the non-functional is there's four main focus like the security, performance, reliability, and usability. So for the security, we implement the GPT token. The performance, we make sure that the API should be fast. The usability, we use the UI must be responsive, and the maintainability, we make the code should be structured and modular. Okay, we go to the chapter 2. So the chapter 2 is explain about the system thinking. So the system thinking means that the website is fully integrated ecosystem. Each component has a specific role and mutually influence the other. So there's just four main element in our system. The first one is user, the second one front end, and the third one back end, and the fourth one is databases. So this diagram is explain the interconnect between the element. So if you want to see the details of the diagram, you can click this link, and I'm gonna explain the interconnect between the elements. So the first one is user and front-end relationship. So the basic interaction, the user access the website, and the JavaScript is gonna handle the browser. And the second one is front-end and third-party service. Like we use Google authentication to log in. So the front end doesn't go to the back end first. The front end requests login into the identity provider, which is Google authentication. The third one is front end and back end. So this is the main communication channel for the application. The front end send the request to the back end using fetch, and this is the detail endpoint that we use. And the fourth one is backend and database. So the backend is only component allowed to talk into the database directly. And there's a 5, 6, and 7 point and so on that you can read. So the chapter 3 is the implementation of design thinking. So we didn't build feature based on our own assumption. Every design decision is grounded in the data and deep understanding of user need. So our method was to distribute a questionnaire complete by 20 respondents, including university and high school students. So there's a few questions that we already give, like the system element and the interconnection, and the identification of learning difficulty, and the validation of the quiz feature, and so on. And we're gonna go to the chapter 5.
Okay. Now let's begin the chapter 4, UI UX designs. First, we defined our primary screens. As you can see in the first table on this chapter, we broke the application down into core user goals, form for orientation, and materials for browsing, and quiz and labo for interaction, and profile for management. This information architecture ensures every screen has a clear purpose. And next, the sitemap. This diagram in this section shows our clear flat navigation structure. From the home screen, a user can directly access every main functions. This structure makes the application easy to navigate and ensure key actions are reachable in just one or two clicks. Now let's talk about responsive design. As our user research in chapter 3 showed, while 70 to 75% of users on desktops, a significant 30% use on mobile devices. It was critical for our application to work perfectly on all screen sizes. So To achieve this, we established a clear policy. As shown in the table for this section, we defined three size classes. The first is a compact and medium and wide. Our policy ensures a full function party, which means no feathers are hidden or mobile. The layout simply adapts graphically. And here is an example of our design. Here is a compact size, and here is a medium size. And the last one is the wide size of our home pages. And next is a wireframe. And this leads us to the wireframe. In the next few pages, we show the structural blueprint for every key screens. The first one is the home. The home page, for example, uses a three-column layout, a wide screen, but stacks a single column on compact. And we also mapped to the virtual labo with its controllers and simulation areas. And we detailed the quiz flow from topics section to the question screen. This wireframe was our essential guide for entire front-end implementations. And next is a color design. In this section, we detail our color design. We choose a light, soft, numerous, thick style, which uses subtle shadows for visual depth. To ensure consistency and accessibility, we defined a strict color token system shown in the corresponding table. For example, the primary used for all main buttons, and the error is used for validation messages. You can see the final result in the screenshot bodies. And finally is typography. For typography, we chose pop-ins of our primary typeface. It's clean, modern, and highly readable. And let's move on to chapter 5, software modeling using UML. This is where we translated our feathers into a formal technical plan. First, we defined our scope and stakeholders. We identified two main actors, the guest and the runner. The definition was crucial for understanding the system boundaries and required functions. And yes, the leads directly to our use case diagram. This diagram is a high-level map of our system functioning. You can see the runner actor on the left connected to primary functions like take quiz and perform virtual lab experiment and update profile. We also show how these cases include other essential behaviors like get quiz progress and save quiz progress. And next is our second model. And let's look closely at the take quiz sequence diagram. This diagram was essential for coding our front end and back end teams. It shows an exact step-by-step flow of communication. So first, the runner starts the quiz. The front end validates the starter JWT token, and next, it sends a GET request, including the token to the back end. The backend versus the token to the reads and users progress from the Firestore database. And finally, the database returns a progress JSON, which the backend forwards to the front end to render the quiz sessions. So we created a similar diagram, the login flow, to model all critical interactions. And next is traceability. This section provides a traceability matrix. The table here connects every use case directly to the specific API endpoint and implement like it. And this matrix proves that every single requirement is met by a concrete piece of our implementations. And next is chapter 6. And to manage our work, we created the Gantt chart diagrams shown in this section. We broke the entire project into 5 main stages. The first is design, research, and prototyping. And next is front-end development and back-end development. And next, front-end and back-end integration. And finally, the deployment. As noted, the following section, the chart also helped us identify our dependencies and critical paths. We knew that integration couldn't start until both the front end and back end were ready, which allowed us manage our time effectively. And for cost estimations, we first calculated our labor effort. We use a 3-point part method, which you can see in the first table of this section. And here is the estimated our non-labor cost. As shown in this final table, we are able to leverage and coverage fees trials for all our essential services. And next is Stefan.
Okay, so I'm gonna explain the seventh part. So let's move the seventh part like the Ryota already explained before. We have 5 steps that we do to make this website. So I gonna explain the technology that already used to make this website. So in the first, we use prototyping or Figma and Draw.io that to devise the idea of for the core page, user navigation flow, and essential UI component. And then after we get the design, we make the front end implementation. So the tool we use is HTML5, CSS3, and vanilla JavaScript ES6 first. So the reason we use this because it's lightweight and give full performance control and avoid framework overhead. So the core our front end is simulation engine we built in lab.js, which use that to ensure our physics simulation animation run smoothly. So the second one is the backend server like logic. So the tool we use is Node.js, Firebase Admin SDK, and JSON Web Token. So our architecture is structured with an authentication middleware that acts as a gatekeeper to secure endpoint and modular control. And for the fourth one, is authentication and token flow. So the process is brief. The user logs in the Google on the front end and gets Google ID token. That Google token is sent to the backend, and the backend validates the token and uses our internal application GWT, and the internal GWT is what stores in the front end local storage and used to access all our secure APIs. And for the deployment and API migration, the front end using Vercel to deploy, and our backend was deployed to Railway. So the most important and technical step was the API migration. So the involved changing to the on the front end is stop calling the local host and we start calling the live URL from the Railway in here. Okay, so we're gonna go to the API summary. So there's many API summary that we use, but I won't go through every single endpoint. But broadly speaking, our API serves as the contact that connects the front end and back end. So we have 3 main group of endpoint. The first one is authentication, like post register, like post login, post authentication in Google, and profile management, like get user data, post update profile, and the third one is progress management, like the get progress quit or post progress quiz. Okay, so this is the explanation of the API, like we get the description, method, authentication, request body, response, if it's okay, and error. Okay, you can read it, all of this, and I'm gonna go to the final chapter of final result and evaluation. So we can conclude that have been successful implement as a fully functional full stack web application with a clear separate between client side and server side logic. So there's following core functional are working nicely. So the first one is authentication and session management. So user can register and login is using traditional username or and password or via Google. And the second one is virtual lab. So simulation of for all 4 topics, and the third one is quiz system and progress tracking. So the quiz module successfully load question and calculate score, and the user can save and retrieve user progress. And the fourth one is profile management. So user can view and update their data and can change what they can see what they already do. So the last one is evaluation. So this is the data that we save into the into the database, and the improvement. So there's a 3 point. So the first one is a loading indicator. The second one is clearly feedback. The third one autosave for quizzes, and there's a profile technician and error monitoring. So that's all from us.
Okay,
Thank you.
Thank you.
Ah, stop. Ah.